much like we saw with our synthetic division, if we divide by ax minus b rather than just an x minus k, then we have to put in b over a. The same is true with the remainder theorem. So notice that p of x, if I had divided by ax minus b, well, I know that I would plug in x minus b over a with my synthetic division, but then I would have to factor an a out of my quotient so that I could multiply it back in to end up with my ax minus b. That's always going to end up being true. And then if I look at plugging in p of b over a, notice that's going to be 0, and I'll still end up with just my remainder. So when I divide by ax minus b, the remainder is going to be p of b over a. It's just as we suspect. So find the remainder when I divide by 2x plus 5. I can do that by finding p of negative 5 over 2. And then in this case, it's probably easier to do synthetic division than thinking about cubing all these values, actually. But we could still do it. We're going to have 2 times negative 5 over 2 cubed plus 3 times negative 5 over 2 squared minus 7 times negative 5 over 2 minus 3. So here, one of my 2's will end up canceling. I'll end up with negative 125 over 4 plus 25 times 3 is 75 over 4. That's going to be 35 over 2. I'm just going to call that 70 over 4 minus 12 over 4 to give myself common denominators. I'll end up with negative 50 plus 70 is 20 minus 12, 18 over 4, which ends up giving me 9 halves or 4.5.